Hello, everybody. Welcome to lesson 4 of our trigonometry unit. In this lesson, we're going to be talking about 30, 60, 90 triangles. Last lesson, we talked about 45, 45, 90 triangles. Remember, a 45, 45, 90 triangle is just another way of saying a right isosceles triangle. But we discovered that the three side lengths of any right isosceles triangle or any 30, 60, or sorry, any 45, 45, 90 triangle will be proportional to its parent triangle, right? Remember the side lengths of a 45, 45, 90 were 1, 1, and the square root of 2. Well, the 30, 60, 90 triangle is another special right triangle that has very specific side lengths that we can use to find missing sides of triangles that have 30, 60, and 90 as their degree measurements. So with that said, let's go ahead and get started on this. So first thing, before we actually get into 30, 60, 90 triangles, we have to understand what an equilateral triangle is. So what is an equilateral triangle? We should all be pretty familiar with the idea of an equilateral triangle. An equilateral triangle is a triangle with all sides congruent. I got to get my camera out of the way here so we can see this. But all sides are congruent. That's the definition of an equilateral triangle, okay? All sides are congruent, okay? The next thing is then, well, if an equilateral triangle has all sides congruent, that also implies that all three angles will be congruent as well. And that is because it's isosceles, right? Isosceles means that there are at least two congruent sides. And if I was to fold this along one of its corners, so if I folded it down here and folded it over, this angle would line up with this one. And then if I folded it this way, then this angle would line up with this one. So that would imply that all three angles are congruent. Well, what does that mean? If all three angles are congruent, then we can call each one of them x, 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 and x because they're all the same, right? If they were different, we would use different variables. But because all these angles are the same, we're going to call them all the same variable. And we know that the three angles in a triangle always add up to 180. So we can say x plus x plus x equals 180. And then combine like terms here, we get 3x equals 180, which implies that x is 60 degrees. In other words, all the angles are congruent and each angle is 60 degrees. So we can replace those with the angle measurement of 60 degrees. You go, well, what does that matter? You'll notice that our special right triangles, when we get to it, has one of the angles as 60 degrees. Well, here's one angle with 60 degrees. Where does the 30 and the 90 come from? Let's find out. Okay, so if I have a 30, 60, 90 triangle, and I say that one of the sides is 2. I just arbitrarily say 2. Now, the reason I say 2 is because that's the most reduced I can get it when I talk about the other sides, and we'll talk about that in a second. But if one side is 2, and this is an equilateral triangle, that implies that all sides are 2. Okay, so all the side lengths are 2. Well, remember, all the angles will be 60 degrees. We just discovered that right now. All those angles will be 60 degrees. That's great. Well, what could I do? I could take this triangle and cut it straight down the middle. Cut it right down the middle, cut it right in half. Well, what just happened to this angle on the top? This angle was 60 degrees. I just cut it in half. So that implies that these two angles are each going to be 30 degrees, right? That makes sense. And then if I do the triangle sum theorem, we could figure out that this angle here is 90 degrees because in this smaller triangle, 30 plus 60 is 90, and then we subtract that from 180 and we end up with 90 degrees. Or you can see that I cut this directly down the middle, right in half, so that this 180 got cut in half, so that's 90 and 90. But that's where the 30, 60, 90 triangle comes from. It takes the equilateral triangle and it just cuts it right down the middle, slices it right down the middle. Now, what else did it do? Well, it took this bottom length, this length that was 2 units long, and it also cut that in half. So that means each of those sides are now 1 and 1. The distance from here to the center is 1. The distance from the center out is 1 because the total length is 2. And now I can erase a bunch of extra information and we can see that we're left with this 30, 60, 90 triangle. The angles are 30, 60, and 90, and I know two of the sides. So how could I find the third side? The third side, we do the Pythagorean theorem. Remember, it's leg squared plus leg squared equals hypotenuse squared. And in this case, the longest side is 2. So we'll call this side x, and we'll say x squared plus 1 squared equals 2 squared. Well, 1 squared is 1 and 2 squared is 4. And then we'll subtract the 1 from both sides. We get x squared is 3. We square root both sides, and we end up with x is equal to square root of 3. That's as simple as we can get it. We're going to leave it as a radical. So that third side is the square root of 3. And now we can say that that is the parent triangle to any 30, 60, 90 triangle. That's the parent one. That's the one that they are all proportional to. They're all related to this triangle. So all 30, 60, 90 triangles are similar to each other, which means they're similar to this 30, 60, 90 triangle. We'd say by AA, we're not going to get into that, but the bottom line is they are similar, which means we can set up ratios just like we have been for the last 2 lessons, okay? So make sure you write this down before we move on to the next part, because we're going to be using this parent triangle consistently for this lesson and into the future, okay? All right, so let's go ahead and take a look at an example of this. So what I'm going to do is I'm going to draw this triangle that I'm given here. Draw this triangle. And we're going to find the missing sides. You go, well, there's not enough information to find the missing sides. I only know a 30-degree angle, a 90-degree angle, and then this side is 4. Normally, I need another side. If this is a right triangle, I could do the Pythagorean theorem on it. But I would need to know 2 of the sides to find the third side. So I can't use the Pythagorean theorem. Let me go ahead and label the 2 sides. The 2 sides are x and y. You can call them whatever you want, but I'm going to call them x and y. Now, I'm going to use the idea of similarity here so I can find the missing sides. Okay, what is this similar to? It's similar to any triangle that has a 30 and a 90-degree angle. Well, what do we know? We know that if this is 30 and this is 90, that this angle here is going to end up being 60, right? 30 plus 60 plus 90 is 180, and we already talked about that anyways, okay? And so that'll be 30, 60, 90. So we know that these 2 triangles are similar to each other. So if I want to find the things in this triangle, I could do that if I knew the things in this triangle. So what we need to do is go back to our parent triangle that we had in the previous slide, and we need to make some connections here so we can make sure that we put these in the right place. Notice a 30, 60, 90 triangle has side lengths of 1, 2, and square root of 3. Well, if you were to type the square root of 3 in your calculator, the square root of 3 is going to be something like 1.7-ish, okay? We would see that the square root of 3 is actually smaller than 2, right? And we see in this triangle, the longest side is always opposite the right angle. It's always the hypotenuse. The longest side in the 30, 60, 90 triangle, parent triangle, is 2. So if we go back over here to our parent triangle, if we were to redraw the parent triangle here, where would the 2 go? The 2 would go across from the 90-degree angle. And notice that the 1 here, the 1 is the smallest side. It is always opposite to the 30-degree angle. It's always across from the 30-degree angle because the 30 degrees is smaller than the other 2 angles, and 1 is smaller than the other 2 sides. So where does the 1 go in our parent triangle here? It goes opposite to the 30, so we're going to put the 1 there. And then we'll notice that the square root of 3 is opposite to the 60. It is across from the 60, or we could say that it's in between the 30 and the 90. So across from the 60, or between the 30 and the 90, is our radical 3, okay? So this parent triangle is going to be absolutely essential in figuring out missing side lengths. We've got to know these 3 lengths, so I could use them to find these 3 lengths, okay? So now we're going to just pick a side. Let's say I pick x. Well, what does x correspond with in the other triangle, in the parent triangle? X corresponds with 2. We're going to say equals 2. Now I could say y over rad 3, but that would be 2 variables. So I'm just going to stick with 4 over 2, okay? Because there's no variables there, okay? So x times 2, cross multiply, x times 2 is 2x, and that will be equal to 4 times 2 which is, and I did this wrong, whoops. It shouldn't be 4 over 2, it should be 4 over 1. 4 corresponds with 1, whoops. Cross that out. X times 1 is just x, and 4 times 2 is 8, and we just solved for x. Boy, did a lot more work, a lot of wrong work along the way there, okay? So we've got x equals 8 here. Now what about y? Well, if we pick y over, what goes with y? Y goes with radical 3, and that would be equal to, and I could use either one now because I know either one. I'm going to just stick with the same ratio as I had before, 4 over 1. Remember, when you're setting up your ratios, if you're going to pick x to go on top, you need to make sure that everything else in that triangle also goes on top in every other fraction. So x is on top, 2's on the bottom. That means 4 needs to be on top and 1 needs to be on the bottom. Same thing over here. Since y is on top and rad 3 is on the bottom, that means everything from this big triangle needs to go on the top. So 4 goes on top, and then everything in this triangle has to go on the bottom, so 1 goes on the bottom. Then we will cross multiply. So 1 times y is y. And then 4 times radical 3. Remember from prior lessons, we can't multiply those together because one's in the radical, one's not. So we would just write it as 4 radical 3. And so that's our answer for y, 4 radical 3. So we just found the missing side lengths of this 30, 60, 90 triangle. The important thing is to make sure you have the correct side lengths in the right places in comparison to the 30, 60, 90. All right, with that said, oh, I already kind of did that. Let's go ahead and do some practice problems. You guys go ahead and do these 2 problems and see how you did. And when you're done, come back and compare what you did to what I have here, okay? So let's see. So for number one, we have, we'll draw the triangle that we're talking about. A little out of scale here, but that's okay. We've got A, 90 degrees, B, 14, and we have 60 degrees. Well, let's go ahead and draw a parent triangle right next to it. We know that the parent triangle is going to be a 90 and a 60 because those are the same. And then this angle is going to be a 30 because it's 30, 60, 90. You have to add up to 180. And then we have to fill in the right places on this 30, 60, 90. Remember, the hypotenuse is always 2 in a 30, 60, 90. The 1 is always across from the 30, and the rad 3 is always across from the 60. And now we can set up to find A and B. So we'd say A over, what does A correspond with? A corresponds with 1, equals, we could say B over rad 3, but that's 2 variables, so we'll say 14 over 2. And then we'll just cross multiply here. Maybe you see a little shortcut here, but that's okay. A times 2 is 2A. And that would be equal to 14 times 1, which is 14. And then we'll go ahead and divide by 2 here. And we end up with A equals 7. So we've got A. For B, we would say B over rad 3 equals, B over rad 3 equals 14 over 2. Cross multiply. So we end up with 2B. Oops, can't see my work here. And then equals to 14 times rad 3. I can't put those together, so we're just going to write it as 14 radical 3. And then we'll divide it both by 2. So we end up with B equals 7 radical 3. So we have our 2 values for number 1. B is 7 radical 3. All right, so that's number 1. Let's go ahead and take a look at number 2. Number 2, we have another 36. Well, we got a 30 and a 60. What's that other angle? How do we know what that is? Should be pretty straightforward, right? If this is 60 degrees and this is 30 degrees, then this one has to be 90 to make it a 30, 60, 90, to make it add up to 180. We've got D, we've got 12, and we have C. So let's go ahead and draw the parent triangle right next to it. Make sure the sides look the same, just maybe smaller. We've got the 60 degrees here, the 30 degrees there. Remember, the hypotenuse is 2. The one opposite the 30 is 1. The one opposite the 60 is radical 3. And now we can set up our ratios. So picking C, I'm going to put C over 1 equals 12 over radical 3. Now, I could cross multiply, and I will just for good measure. I get radical 3 times C equals 12 times 1, which is 12. Okay. Then from here, we're going to divide by the square root of 3. This is the only tricky one we have to be careful of in the 30, 60, 90s, okay? C equals 12 divided by radical 3. Remember, we can't have a radical on the bottom, so we multiply by the conjugate thing, radical 3 over radical 3. And on top, we'd end up with 12 radical 3. And on the bottom, radical 3 times radical 3, remember, is just 3. And then we can reduce the top and the bottom, both by 3. And we end up with 4 radical 3 over 1, or just 4 radical 3. So we have C here is 4 radical 3. Okay, that's a little bit trickier because we have the radical on the bottom, but that's okay. Okay, for D, we're going to say D over 2 equals 12 over radical 3. Cross multiply, we end up with radical 3 times D equals 12 times 2, which is 24. And then we're going to go ahead and divide by the square root of 3. And we end up with D equals 24 over radical 3. But again, we have a radical on the bottom, so we have to multiply by that by rad 3 over rad 3, which turns into 24 radical 3 over 3. And then we can reduce the 24 and the 3 by 3. We end up with 8 radical 3. Okay, so now we have D. D is 8 radical 3 there. Okay, all right, that's how you find the missing side lengths of a 30, 60, 90 triangle. You have to compare it to its parent triangle there. Now, I want to take a step back and I want to compare the two special right triangles that we've talked about so far, right? So far, these are really the only ones, okay? We have the 45, 45, 90 triangle. And remember the 45, 45, 90 triangle, the side lengths were 1, 1, and radical 2, where the square root of 2 is the hypotenuse, right? 1 and 1 are the same because those are across from the 45 and the 45, and the radical 2 is across from the 90. So we say it's a 1, 1 radical 2. We could say 45, 45, 90 is a 1, 1 rad 2. For a 30, 60, 90, we have, there's our 30, 60, 90 degrees. Remember, the 2 is across from the hypotenuse. The 1 is across from the 30, and then the rad 3 is across from the 60. So if I'm going to put them in order, right, since I have 30, 60, 90, I'm going to put them in the same order. What goes across from the 30? The 1 does. What goes across from the 60? The radical 3 does. What goes across from the 90? The 2 does. Now you can see where students would have a hard time memorizing these. They might mix up the two triangles, right? So you're going to want to put some extra effort into knowing where things go. You can see that the hypotenuse both have a number 2 in it, but this one has a radical, okay? So you have to be careful with that, right? So just commit this to memory that a 45, 45, 90 is a 1, 1 rad 2, where the rad 2 is the hypotenuse. The 30, 60, 90 is a 1 rad 3 and 2, where the 1 is opposite the 30, the 2 is the opposite the 90, and the rad 3 is opposite the 60, okay? All right, let's go ahead and take a look at 2 more problems that are a little bit more in depth. And I'm actually only going to do the first one, and I'll just give you the answers to the second one, okay? In the first one, we see that we have two triangles. We have, let me move this over so we have room to work, okay? All right, in the first one, we have a right isosceles, and then in this triangle, we have a 90 degree and a 30 degree. Okay, so what does that mean? Well, let's just break it apart and focus on one triangle at a time and find what we can in that triangle. The reason I picked the isosceles triangle, the reason I picked this one is because this is the one where I knew the value. I only know 32 degree or 32 here. That's 32. Now, because these side lengths are the same, that implies that the angles are the same, which means it has to be a 45 and a 45. It can't be 30 and 60 because then the side lengths wouldn't be the same, okay? So this is X and this is Y. Well, right off the bat, because this is isosceles, those two marks are congruent, we already know that Y equals 32. There's not any work to do there because they're the same, okay? But for X, we want to set up our special 45, 45, 90 triangle, our parent one, 45 and 90. And remember the side lengths are 1, 1, square root of 2. And now we can set up for x. We'd say x over radical 2 equals 32 over 1. And we'll just cross multiply. X times 1 is x. And then radical 2 times 32 is going to be 32 radical 2. So there I found the two side lengths that were missing in this triangle. So that seems easy enough, right? But now we need to use that information to find the other side lengths, okay? So if I go down to, let's looking at the 30, 60, 90 triangle that I have there. This was my 30. This was my 90, and obviously this has to be a 60. We know this is W and this is Z. We also know this is Y, but we already figured out Y before. Remember, Y is 32. So I can put that here. I could say that this is 32. And I can use that to find the other two sides. So now I'm going to look at my parent 30, 60, 90 triangle. And remember the side lengths. The 1 is always across from the 30. The radical 3 is always across from the 60. And the 2 is always across from the 90. So we would set up a ratio now. We'd say Z over radical 3 equals 32 over 1. And then just cross multiply. Z times 1 is Z. And then 32 times radical 3 is 32 radical 3. So we have Z here, 32 radical 3. For W, same type of thing. W goes with 2, and that's going to be equal to 32 over 1. And then just cross multiply. W times 1 is W, and 2 times 32 is 64. Okay, so that is the answer for number 3. We have all our side lengths. We have x. X was 32 rad 2. We have y, which is 32. We have z, which is 32 rad 3. And we have w, which is 64. Okay. All right, and for number 4, let me see if I can do some of these in my head. Let's see. A should be 8. B should be 8 radical 3. C is going to be 4 radical 6 when you simplify it all. And then D will also be 4 radical 6. And I believe that works. Let's see. B is 8 radical 3. So 8 radical 3 over radical 2. Yeah, 4 radical 6. Okay, so those are the answers for number 4 if you did that problem to make sure you are correct, okay? If you have any questions, please reach out by comment in the chat below or find me in tutoring. Remember, I'm available for tutoring on Mondays, Tuesdays, Thursdays, and Fridays from, from 12:40 to 2:30. Please take advantage of that. Otherwise, I will talk to you again later.